Okay, Foundations in Pre-Cal 10, let's get after it. Here we go. We got a video on solving systems using addition. So you'll see what that means here in just a minute. Now you could technically use subtraction, but I'm just going to stick with using addition. Maybe I'll put an example in there where we subtract instead, but you'll remember that subtraction is just adding a negative, so we can always solve this using addition. So here we go. In this case, we are given two equations, and there's no graphing. We are just going to set these things up and add the equations together using stack addition, right? 5 plus 3 equals 8, so that one of our two variables cancels out. So what I mean by that is we're going to have x plus y equals 6, and then x minus y equals 4. So I've set my equations up so that everything lines up. The x's, the y's, the equals, and the constants. And now I'm going to add these equations together. And you'll notice that I have a bit of a dream scenario here because I have a plus 1y minus 1y. So when you add those things together, you're going to get 0y. So what you end up with is you end up with 2x plus 0y, and you don't have to write the 0y. I'm just showing you that's what happens, right? Gone. That was the hope. Equals 10. So now we can solve for x. X equals 5. Boom. So now what you can do is you take this value you solved for x, right? We know that x is 5, and you plug it into either of these equations. So now x plus y equals 6. That means 5 plus y equals 6. That means y equals 1. So we solve for the point 5, comma 1. And if you want to do your due diligence and you want to check, you don't always have to fully do it, but we have 5 plus 1 should be 6. That's easy to see is true. And 5 minus 1 should be 4. And that's easy to see is true. So that is the goal here. That's what we're trying to achieve. So let's look at another one. Now in this case, we have one equation in slope-intercept form, this one right here. So let's get rid of that first. And I know in standard you're supposed to have a positive a value to technically be in standard form. But if you look here, I have a positive x, which means having a negative x would actually be very helpful. So I'm just going to subtract x from both sides because that gives me negative x plus y equals 4, and then x plus 2y equals 5. Because now when I add those together, my x's cancel out, and I'm left with 3y equals 9. So y equals 3. Plug that into either of your equations. I'm going to plug it into this one. So 3 equals x plus 4. Subtract 4 from both sides. And negative 1 equals x. So that gives us the point negative 1 comma 3. And again, do your due diligence just to check. And that means that when y is 3, x is negative 1. And that is true there. And when x is 3, y is negative 1. Or sorry, other way around. When x is negative 1, y is 3, and you can see that's negative 1 plus 6. So again, we're good. So far things have been relatively straightforward because our variables have canceled out right away. But in this scenario, you can see we have 2x minus 3y equals 2, and then we have x plus 2y equals 8. Now, this isn't helpful because if we add these together, we're still going to have both our variables. So if you remember from grade 9 algebra, we could get rid of multiple fractions by multiplying the entire equation by the LCD. Well, in this case, we're not trying to get rid of denominators. We're actually trying to get rid of an entire variable. So we want an x term in one equation to be the opposite of the x term in the other. So if you look at this equation down here, if I multiply this by negative 2, I would have 2x and negative 2x, which is perfect. But remember that means I have to multiply that by negative 2, and I have to multiply that by negative 2. You have to multiply the entire equation by negative 2. So that changes my scenario. That now gives me 2x minus 3y equals 2, and then negative 2x minus 4y equals negative 16. So what that gives me when I add them up is now my x's cancel, but now I get negative 7y equals negative 14, so y equals 2. Now it's a very good habit to plug that value into the equation you did not manipulate. Okay, so we'll take this equation that we didn't manipulate, and we're saying that 2x minus 3 times 2 is 2, so that means 2x minus 6 is 2. Add 6 to both sides, 2x equals 8, so x equals 4. So we get the point 4, comma 2 as our solution. And let's do our due diligence here. Let's check, check, check. So when x is 4, we have 2 times 4 minus 3 times 2. Well, that's 8 minus 6, so we're good. And then here we have 4 plus 2 times 2, which is 4 plus 4, so we are good. So you might have to manipulate one equation. In instances, you might have to manipulate both. So let's keep going. So here's another example. So here we have 4x plus 3y equals 5. And then we have 3x minus 2y equals 8. Now, you look at this one, and there's nothing you can multiply one equation with so that they'll cancel out, other than a fraction, but things would get messy. Don't do that. So what we will do is pick either one. I'm going to get rid of my x's and just look at the two coefficients. Here you have a 4, and here you have a 3. So if you multiply them by each other, they will then become 12, but we need one of them to be negative. So what I'm going to do is I'm going to multiply this entire equation by 3, but I'm going to multiply this entire equation by negative 4. So what I end up with is 12x plus 9y equals 15, and then I have negative 12x plus 8y equals negative 32. So watch your signs, and now I'm going to add them together. You can see my x's disappear, and I end up with 17y is equal to 32 minus 15 is 17, so negative 17. So that means y is equal to negative 1. So from there, I can plug it into either equation. I'm going to pick this one. Don't plug it into the equations you've changed. Plug it into one of the originals. So 3 times x minus 2 times negative 1 should be 8. 3 times x plus 2 should be 8. 3x equals 6. I've subtracted 2 from both sides, and then divide both sides by 3. X is 2. So you get the point 2 comma negative 1. So again, due diligence. Let's check and see if we are correct. That's the beauty with this stuff. You can check your own answers so you'll know if you're right or not. We get 4 times 2 plus 3 times negative 1. Well, that's 8 minus 3, so that is 5. And then we get 3 times 2 minus 2 times negative 1. Well, that's 6 plus 2, which is 8. So we're good. So again, there is your solution. So let's keep going. So another example. Here I have 3x minus 2y equals 1. And then I have negative 6x plus 4y equals 3. Okay, so obviously I can't just add these up, but I can multiply this one by 2. And that's going to give me 6x minus 4y equals 2, and then negative 6x plus 4y equals 3. So now something interesting is going to happen here. The x's cancel out, right? You get 0x, but so do the y's. But the right side of the column is 5. So you end up with this statement, 0 equals 5. And that's not true. That's never going to be true. 0 does not equal 5. So if you end up in that scenario, be okay with that scenario. That is this scenario. No solution. And remember that what did no solution means when we graphed? No solution graphically meant they were parallel. So just to show you that, let's convert these into slope-intercept form. We'll subtract 3 from both sides and divide everything by negative 2. You end up with 3 over 2x. I'm going to stop there because all I care about is that. And then this one, if you subtract or add 6x, to both sides, you end up with 4y equals 6x plus 3. And then divide everything by 4, you end up with 6 over 4 as your slope, which we know is the same as 3 over 2. So they have parallel slopes and they have different y-intercepts, which is why we have no solution. So if you end up in this situation, you have no solution. So here's another one. And you can almost probably anticipate what's going to happen here. Now in this one, we are almost close to being able to eliminate, but we can't. So we're going to multiply this entire equation by 2. And what that gives us 4x plus 10y equals 4. And then negative 4x minus 10y equals negative 4. And now in this case, we get 0 equals 0. And that is true, and that's wonderful. So guess what that means? These are the same line, so we have infinite solutions. So All three of those scenarios are true. You will either get one set of ordered pairs, or you will get a 0 equals 5 scenario or a 0 equals 0 scenario. Know the difference between the three, be comfortable with the three, and enjoy it. So that is how we solve systems algebraically using the addition method. Convert those equations when you have to. Be diligent that you're rewriting the equations properly, but it's a really interesting and cool way to solve a system without having to graph. So hope you enjoyed that video. Stay tuned for one more on how to solve via substitution.